The function n of t equals 251 times e raised to the 0.01t approximates the United States population in millions of people, where t is the number of years since 1990. And here we have three questions. A, what was the approximate population in 1990? Well, 1990 is 0 years since 1990, so for part A, we're just evaluating n of 0, which would be 251 times e to the 0.01 times 0. Now, if you just reach for your calculator, put it down, 0.01 times 0 is 0. A number raised to the 0 power is 1. This is 251, and I need to remember that this is in millions of people. So the United States population in 1990 was approximately 251 million people. The next problem I think I will have to use my calculator for, I'm asked to approximate the population in 2036. What will the population be in about 2036? All right, so I'm using the same function. N of t is 251 e to the 0.01t, but now I need to plug in an amount of time that would correspond to 2036. 2036 is 46 years after 1990. All right, so this time I am going to reach for my TI-84 calculator, 251 times, and I'm going to use the E button, which requires me to hit second, and then the natural log button, and we'll talk about natural logs next week, but for now, second, and then E raised to the 0.01 times 46. And I get about 397, and I'm just going to say 0.6. I think it'd be fair to round that up to 398 since we're not given any rounding instructions, but I'm going to leave it as 397.6 million people. In 2036, the population in the United States will be about 397.6 million people. Okay, and then finally we're asked to approximate the year in which the United States population will reach 500 million people. Well, this is a bit of a tough question for us right now. Later on in the class, we'll find a way to solve this as an equation, because what this really is giving us a number of people and asking us to solve, which will require us to deal with a variable and an exponent while we're solving an equation. We will do that, but for right now, I kind of want to do this as an exploration. So later in the course, we'll be able to solve this equation. And by the time the test rolls around, that will be the better option for solving an equation like this, because we'll get a precise answer. But what I'd like to do is use a feature in my graphing calculator to approximate this right now. So I've entered my function in 251 e raised to the 0.01 x from the variable button. The calculator doesn't understand t, so we're just going to call it x. And now I want to use the table. And I'm going to look through the table until I see 500, because I'm asked about 500 million people. But first I'm going to hit second and go into table setup by hitting the window button. So second window. Most of the time when I'm using the table, I like to ask things, right? I put in the x's, it tells me the y's, but I'm going to make it be auto. I don't want to start at 0. That would correspond to 1990, and I know the population there was 251 million, about half of what I'm looking for now. In 2036, there was 398 million people. So I'm just going to start it at 50 years since 1990. And I'm just thinking that that might be closer to where I'm going. We could scroll through the whole table if we had to. So now that I have that set up, I'm going to hit second and go into the table. And what I'm going to do now is I'm just going to scroll down until I see 500 in the column for Y, because that will be 500 million people. So it looks like it happens between year 68 and year 69. I'm gonna say go with the 69th year. But we need to remember that that was 69 years since 1990. All right, well, 1990 plus 69 years is 2059. The year in which the United States population will reach about 500,000 people, according to this model, which would assume nothing changes, will be about 2059. Again, later on in the course, we'll be able to solve this a better way by actually solving an equation and not having such a rounded figure there from just scrolling through a table on a calculator. I think you can go on and think about why it might be nicer to solve an equation, because what if that was way down on the list and we didn't have any idea where to start looking? We could be scrolling through a calculator forever. And what if it never showed up in the table? Solving the equation will be the better way to go. But for now, at least we're able to answer an interesting question about this population model.